Here's a question that deals with a common misunderstanding. When it comes to confidence intervals, let's say I have a lower confidence limit of, I don't know, I'm making this up. This is just for the sake of example. Let's say 40 and an upper confidence limit equals to 60. So my estimation runs from 40 on the low end to 60 on the upper end. And let's say that I'm estimating the population mean. Have a look at what it says in the question. It says, a proper interpretation of the limits of a 95% confidence interval of a single population mean is... So basically, if this was my result, my lower and my upper confidence limit, when I'm estimating the population mean, what is the proper interpretation? Now, part A gets at actually, right away they get into the correct interpretation. So this is the right answer. It says 95 times out of 100, the sample mean will produce a confidence interval with limits that contain the true population mean. So how do I know that this is the right one? Well, let's have a look at the remaining ones, and I'll show you how they cannot be the correct answers. Part B says, we're 95% confident that the true population mean falls between these limits. Okay, so this one is wrong, but why is this one wrong? Well, let's have a look at our example. Now, we have a lower limit of 40 and an upper limit of 60. And let's say that my confidence is, let's change this. Let's say that my confidence is 95%, like they're suggesting in the question. So it's a 95% confidence interval. Does it mean that I'm 95% confident that the true mean falls somewhere between this lower limit and this upper limit? So I'm 95% confident that it falls somewhere in this range. That seems like a reasonable thing to say. It seems like that's what a confidence interval should be all about, what an estimation should be all about. But the problem is that that suggests that there's a 95% chance that the true mean does something. It does something in the sense that it falls in this range here. Well, the true mean has a value. It's a value that we don't really know, but it's not a value that's governed by probability. The value of the true mean is a set value. It doesn't have a probability associated with it. It simply is what it is. Let's say that the true mean equals to 43. Now, if it's 43, there is no chance that it's anything else. It simply is just a 100% chance that it's 43. There's nothing to do here with 95%. This is not governed by probability. What is governed by probability is this. If you had a population where the mean is 43, and you were to take a sample from that population, you might get a sample mean that's equals to 43 that properly represents the population, or you might get a sample mean that's equals to 46. Samples can show samples can have averages that are higher than the population average. Think about your class. Imagine in your class that the average is 70. I could come into your class and grab a sample of 5 students. Those 5 students might be below average. They might have an average of 50 amongst them. They might have an average of 75. They could be 5 of the top students in the class and have an average of 98 amongst them. I could really get any kind of a sample mean from just a single population. Sample means can be governed by probability, but not population means. They have a set value. It doesn't act according to probability. So it's incorrect to say something like, we're 95% confident that the true population mean does something. It doesn't act according to probability. So in fact, if we're 95% confident that the true population mean falls between these limits, or 95% chance that the true population mean falls between the lower and upper limits, or there's a 5% chance that the true population mean falls between the lower and upper limits, all of these have to do with a chance that the true population mean does something. And in all cases, this is wrong. There is no chance of the population mean doing anything. Let's go back up to part A. It says 95 times out of 100, the sample mean will produce a confidence interval with limits that contain the true population mean. So what's going on here is that this is a probability of the sample mean doing something. And like I said before, the sample mean can take on many different values. And so I can have a chance, 95 times out of 100, that's basically the same as saying 95%, there's a 95% chance that the sample mean will do something. It'll give us the correct answer. So this is the right answer.